Okay, today's section 5.3a, we'll be talking more about trigonometric graphs. Now here we're talking about shifted sine and cosine curves. So here we'll be talking about period and phase shift. Okay, so on the last video we talked about amplitude, so that's the stretching of your or shrinking of your sine graph vertically vertically. Okay. And then vertical shift is the moving or translation up and down of your sine and cosine graphs. Here we'll be talking about the stretching or the shrinking of the sine and cosine graphs like horizontally. So that's where the period comes in. And then phase shift is the movement or the translation of your sine and cosine graph along the x-axis. Okay. So kind of like the opposite ones from the last video. So that's where these two kind of equations come from. So that's why we're adding a x minus b in there. We still have amplitude, but here we won't really worry about our amplitude because we won't have a number. We won't move it up and down so much. We'll just worry about our period and our phase shift. And then the next video, we will try to put everything together all at once, and so you can kind of see how we deal with them when there's multiple of them to talk about. Okay, so here the period changes when we put a number in front of that x value. And notice how these functions are written out. So to correctly manipulate the period, you need to factor out the k value, because that will change what your phase shift looks like, that b value, because you need to have that out in order to see what the correct b value is there for phase shift. So that's why it's kind of written like that. So it's not like kx minus b all with no parentheses, but the k is outside times x minus b. Here, like I said, when we change the k value, it changes the period. Okay, now here, when it's a bigger k value, it shrinks your period, so it makes the horizontal shrink, or shrink horizontally with the x-axis. If it's a number less than k, or 1, so in between 0 and 1, so a fraction, then it actually makes it larger. Okay, so it's kind of like an opposite effect there. Phase shift is just the value that tells you. Now those ones, just so you're aware, b will be in a radian measurement, so they'll have pi in it. So don't be alarmed when you see pi in there, because it needs to be able to subtract with the pi that you're inserting, so it kind of makes it like terms in the same sense. So period is going to be the time distance it takes for a sinusoid to oscillate once, so that could be short or it could be a long time. Phase shift is the movement a sinusoid shifts that sinusoid will along the x-axis. Okay. So the next example that we have for this is we have cosine of 3x. So here, now this is where my little trick ends up happening. Okay, so the first thing is you have 2 pi over k. Now you need to recognize what your k value is in this, which it looks like it'd be 3 because it's the number multiplied by x. So what I want to do to be able to figure out what my x values are that I get to plug in, so I can get those normal ratios. Okay, I'm always trying to get those normal ones. So then 2 pi divided by 3 gets me 2 pi over 3. So this would be the new period. Okay, so that is the length or the distance between the starting point and then the next starting point. So it the next time it starts to repeat again, because it's always going to repeat itself, but you just want to be able to graph once. Okay. So here, 2 pi over 3, now to get these values, Now you always start with 0, okay, because that's kind of like, remember our b value is going to be that first interval. Let's go back so I can show you that. So there's that complete value. Since we have no phase shift, our b value is 0 in this case, okay? So that'll be our first one, right? Now I want to take that 2 pi over 3 and I want to divide it by 4s. So then that gives me the increments of which to go by for each value until I've got 5 total numbers, okay? Because I'm basically going to go to 2 pi over 3. So since there's no phase shift, it's easy to see when you're going to end because you know the period, the length, okay? So I should have 2 pi over 3 here, okay? So dividing by 4, now because it's a fraction, that's the same thing as multiplying by the reciprocal, 1/4. So then you can reduce a 2 out of there. So then I actually get pi over 6. Okay? So I'm going to go by pi over 6 for every value. So you start with 0, add a pi over 6, gets me pi over 6. Adding another pi over 6 gets me 2 pi over 6. Okay? Which reduces to pi over 3. Okay? If I add another pi over 6, so let's go back. You had a pi over 6 plus pi over 6, 2 pi over 6, which was this one. Okay? If I add another one, that's 3 pi over 6, which equals pi over 2 if you reduce. Okay? So now, and then if I added that again, another pi over 6, I get 4 pi over 6, which reduces to 2 pi over 3, which was the last one that we came up with, which we already knew that was going to be the end point anyway. So that's all I have to map my stuff to. So that's how I'll label my graph here, so I know what values I'm doing. So anytime, like for every graph, you need to label the values that you're going by or your scale, because it will change as you're doing different graphs because of the period and because of the phase shift and all that stuff. Okay, so always label your scales so that we know what you're talking about or what those values are. Okay, don't assume that we know. Always label. So if I plug in 0 to my function here, cosine of 3 pi, and let's do a little work over here. So cosine of 3 times 0, okay, get you 0. So 3 times 0 is 0. Cosine of 0 is going to be 1, okay, like it has been before. If I do cosine of 3 times pi over 6, remember, multiply across, that gives you cosine of pi over 2. Notice that that was the ratio that we would have had before if we didn't do any period movement or change. So then cosine of pi over 2 is 0. Then if I do cosine of 3 times pi over 3, notice how the 3's cancel out. You get cosine of pi, which is -1. Then cosine of 3 times pi over 2, multiply across, get you cosine of 3 pi over 2. Let's write this so you can kind of see the pattern. So 3 pi over 2 is 0 again for cosine. And then for cosine of 2 pi over 3 times 3, the 3's cancel out. What are you left with? Cosine of 2 pi, which is 1 again. So notice how we got those values that we had earlier, but we got them because we picked values for our x's to plug in, so we got nice numbers. So that's my reasoning for like why we want to kind of shift those x values so we can get nice numbers when we plug them in. Because I don't want you to have to graph square root of 2 over 2 and have an approximation there, because that makes it a lot harder for you to graph, and it takes a lot more time to try to figure out what that is. So graphing 1, 0, -1, 0, 1 is way easier than dealing with all that extra stuff. So if I graph those numbers, let's try that one again. There you go. So there's my graph. Okay? Let's try the next one. Now here, we're talking about phase shift. Okay? So this one is going to not have a period change because the value out front is 1. So we're still going from our length of 2 pi. Now the difference here is that we shift it. Now notice how in the previous thing for the formula it says minus b, okay? So it's going to be the opposite. Just like it would be in, like, if you had x minus 2 squared, it would shift it to the right 2 instead of to the left because of the minus. So here, because it says plus, that means I'm shifting to the left pi over 6. Okay? So I have a normal period of 2 pi, but that means all my x values need to shift over a value of pi over 6 to the left. So you're going to take away a pi over 6. So you would have 0. You would have pi over 2, like normally. So think about our division. Our increments are by 2 over 2, because we have a normal period of 2 pi. Then you have pi, then you have 3 pi over 2, and then you have 2 pi. Okay? Now, if I shift them, so that means I'm moving to the left, so it's always going to be the opposite of the plus sign, so, or the sign in there. So I'm going to subtract pi over 6, because you want to be able to get back to these numbers, okay, when you plug them in to your trig function, so you can get the nice stuff. You don't want the crummy values that are hard to graph. So if I subtract pi over 6 from 0, let's write that operation. So that gets me negative pi over 6. Okay? If I subtract pi over 6 from pi over 2, remember that makes that 3. So it gives you 2 pi over 6, or pi over 3. If I do the same thing for pi, remember that's 6 pi over 6. Okay? So you hopefully see the pattern here. I'm making common denominators. So then here for that one is 9 pi over 6. So that gives me 8 pi over 6, which is 4 pi over 3. And then for 2 pi, that's the same thing as 12 pi over 6, which you subtract 1. That gets me 11 pi over 6. Okay? So then these are the values I'm going to plug in, and that's what I need to map on my graph here. Now, for this one, maybe I made my graph a little bit too wonky. Let me fix it for you. Okay, so now I can graph these. So let's say this is negative pi over 6. This is pi over 6. Okay. Now because you set the scale right there, you don't need to label every single one. So I would say that pi over 6, pi over 3, pi over 2. So pi, 3 pi over 2, and then 2 pi. Okay. So then you can get a basic idea of what's going on, but you have the scale set, so then your stuff will be correctly graphed. So now if I plug in negative pi over 6, okay, if I plug that in, negative pi over 6 plus pi over 6 gets you 0, because they cancel each other out. So sine of 0 will be 0. Okay? Then here, if I plug in pi over 3, so remember that was 2 pi third, or 2 pi 6, plus pi over 6 gets you 3 pi over 6. That's the same thing as pi over 2. Notice how we're getting back to the same numbers that we wanted, which were right there. So sine of pi over 2 is 1. Then I plug in a pi, or 5 pi over 6. So then 5 pi over 6 plus pi over 6 gives me 6 pi over 6, which is pi. So sine of pi is 0. Then plugging in 4 pi over 3 plus pi over 6. Remember, 5 pi over or 4 pi over 3 is the same thing as 8 pi over 6 if you're making common denominators. So add them together gives you 9 pi over 6. So then that reduces down to 3 pi over 2. So sine of 3 pi over 2 we know is -1. And then 11 pi over 6 plus pi over 6 is 12 pi over 6. Reduce that to 2 pi. Oh, sine of 2 pi is 0. So hopefully you see that doing the little calculations here gives us values that actually help us out a little bit better for our picture. Now certainly you could just plug in 0 pi over 2 pi, 3 pi over 2, and 2 pi in if you have your calculator to graph these. Now you may not be given your graphing calculator for a test because we don't want you to use the graphing function on it. So just know that there will be times when you need to be able to show that you can find these without a graphing calculator during one of your quizzes or maybe even your test. So just to prepare you. So that's why I know that, oh, why can't I just graph this in my calculator and just copy it down? Well, the reason being is you may not have it. So knowing the little ins and outs of graphing it this way might be a lot more helpful to you later down the road. Okay. Now in the next video I'm going to show you a little bit or one other way of graphing, just so you have a different option if it maybe makes more sense to you rather than doing it this way. But that's when we're going to put everything together, so it'll make more sense to show you that way when it's all together, so you can see it step by step. Okay, have fun.